Today is implicit differentiation, and I was just thinking how much I really like implicit differentiation. Talked to my sister, and she also likes implicit differentiation. We're weird, I know. Okay. Anyway, so today is all about how do we take a derivative if the function or if the equation is not written in terms of y. So something like this: 2x squared plus 3y is equal to 3, or like maybe think like a circle, x squared plus y squared is equal to 1. Okay, these are implicitly written equations where the y is not isolated. Okay, so what we're going to do is we are going to differentiate everything in terms of whatever variable your equation is written in. So ours is going to be in terms of x for today, or anywhere you can tell by looking at the denominator of the d something, okay? So the way we evaluate or simplify to get a derivative with implicit differentiation is using the chain rule. Okay, so here's the deal. What we're going to do is we're going to find the derivative. This is a normal derivative. Look, we have, we're going to take the derivative in terms of x, so meaning that x is the variable, the independent variable in our function. So right now, the x is the independent variable, so we're going to go ahead and just take the derivative by using our power rule. So 3x squared. Done. Next, I can see now that I have our equation is supposed to be written in terms of x, but I have y variables in my equation. So what we're going to do is take the derivative of y cubed, which power rule tells me that's 3y squared, but then I need to tack on the derivative dy dx. So the derivative in terms of x. Okay, so we're going to add on that dy dx. So we're basically taking the derivative of the inside, which is y. Okay, dy dx. Next up, v. I'm taking the derivative in terms of t, but I have a v, so I have v to the first power. This is going to give me 1 times the derivative of v would be dv dt. Okay, dv dt. So we have to tack on the derivative of the inside function. Okay, whoa, my screen's going nuts. Let us find, whoa, we are far away from where we need to be. Okay, next one, dx of x plus 3y. So the first part, what's the derivative of x? It's just 1. And what is the derivative of 3y? That would be 3, but now we need to take the derivative of just plain y, which would be dy dx. All right, next. So we're always tacking on. If the variable does not match what the equation is written in terms of, we tack on the extra dy dx or dg dx, okay? Whatever it is. So this time we're in terms of x, so the y part of the derivative is going to have to get that extra tacked on notation. So we have product rule here. The left is x, the right is y squared. So I have left d right, right d left. So left is x, d right would be 2y, and then again tacking on dy dx. So making sure we take the derivative in terms of x, plus left, which is, y squared, times the derivative of the right. So the derivative of x is 1. So to simplify, I can just write 2xy dy dx plus y squared. Okay. So just some steps. So we differentiate both sides of the equation, and then using implicit differentiation, and then we're going to gather all of the dy dx's together and factor it out. And finally, we're going to get dy dx by itself. I'll show you what I mean now. Okay, so first off, I can see we have an implicit equation because we have x's and y's on the same side of the equal sign. So we don't have a y equals, we have x's and y's on the same side. So we are going to take the derivative of this first part, which is 3y squared, tack on our dy dx, okay, plus the second part, which is power rule says that's 4y. Again, because it's not an x, we're going to tack on the dy dx, minus the derivative of 5y is 5, and the variable in that derivative was y, so we need to tack on the dy dx. And then the derivative of negative 2x squared would be negative 2x is equal to 0. We do not, oh, you know what? Technically we are tacking on that extra d something dx. It's the derivative of the variable, so dx over what the equation is written in terms of. So dx dx, what is dx dx? That's 1. That's why we don't write that when we take the derivative of the variable where the equation is written in terms of that variable. Okay, so the next step it said was to gather all of the dy dx's on one side. So I am going to add this to x, and that gives me, so that's going to go away. And the next step, I guess I'll write it out, 3y squared dy dx plus 4y dy dx minus 5 times dy dx is equal to 2x. Then I can factor out the dy dx. And this is so we can isolate it. Or y minus 5 is equal to 2x. And then to isolate dy dx, we divide 2x over 3y squared plus 4y minus 5. So the derivative written in terms of x is 2x over 3y squared plus 4y minus 5. Fun times. Let's move on. All right, next one. It looks like I have some product rule here. So left is x cubed and d right is 3y squared, and then tack on our dy dx because y does not match x, okay? And then plus the left, y cubed, times 3x squared. We do not need a dx over dx because that's just 1. Okay, then we're going to subtract out the minus y, so the derivative of y is 1 dy dx, and that equals 1. Do I need a dy dx? No, because the x is going to turn out to be dx over dx. Okay, so next step is to gather our dy dx's on one side. So it looks like I'm going to subtract y cubed times 3x squared. So I get 3x cubed y squared dy dx. That's going to cancel. Minus dy dx is equal to 1 minus 3x squared y cubed. Now we're going to factor out the dy dx. Is going to give me 3x squared, 3x cubed y squared minus 1 is equal to 1 minus 3x squared y cubed. I was just checking, making sure I'm doing this right. Okay, then divide to get dy dx by itself. And so we get, making this pretty, 1 minus 3x squared y cubed over 3x cubed y squared minus 1. And that is it. That's the derivative of y in terms of x. So y isolated, well, y in terms of x. Wow. Okay. Okay, the next one, we're going to determine the slope of the graph of this equation at a point. So the slope of a graph is just the derivative, so we're going to have to take the derivative. So I see some fancy things happening. On the right, I'm going to have to use the product rule, and I'm going to use 100x as the left and y as the right. On the left-hand side, I see chain rule. So the outsidemost piece would be the 3x squared. Okay. The inside piece would be the parentheses. And that's it. Okay. So the outside, I'm going to multiply 2 by 3, giving us 6. Everything on the inside, x squared plus y squared, stays the same. And then our power reduces to a 1. Then I'm going to take the derivative of the inside part, this part, which is 2x. I do not need a dx over dx, plus 2y, but because it's not an x, I need to write dy dx. Okay, next, I am going to do the right-hand side. Making sure everything is good here. Okay, so we have the product rule. So lefty right, righty left. So left is 100x. D right would be 1 dy dx plus right, which is y, times the derivative of the left, which is 100, because 100 is the derivative of 100x. Since we're taking the derivative in terms of x, I do not need the dx over dx, because that reduces to 1. Yay! Okay, now you think this is done, but it's not. We have to isolate dy dx. Cool? So we're going to gather up all of our dy dx factors, terms. Okay, so I'm going to distribute this guy in first. So I have 6x squared plus 6y squared, and then 2x plus 2y dy dx is equal to 100x dy dx plus 100y. Then I'm going to distribute again, giving me 12x cubed plus 12x squared y dy dx plus 12xy squared. And then the last here would be plus 12y cubed dy dx is equal to 100x dy dx plus 100y. Okay, so I'm going to move this guy and this guy to the right-hand side, and I'm going to move this guy to the left-hand side. So I'm going to subtract 12x cubed, subtract 12xy squared, so subtract 12x cubed minus 12xy squared. And I'm going to subtract 100x dy dx. This is gross. It's so much neater on my paper. I apologize. Okay, so when I gather these all up, I get 12 x cubed, right? 12x squared. I'm gonna double check. Make sure my work is good. Come on, screen recorder. Chill for me. Okay, my work got too messy, so I rewrote it for you guys. And then I rearranged so that the dy and dx is on one side. So now I'm ready to factor out the dy dx, leaving me left over with 12x squared y plus 12y cubed minus 100 is equal to, I forgot 100x is equal to 100y minus 12x cubed minus 12xy squared. Okay, now we can divide. So I'm just gonna divide by 12x squared y plus 12y cubed minus 100x. So 12x squared y plus 12x cubed minus 100x. So I get dy dx is equal to 100x squared y plus, oh wait, sorry, wrong side, equals 100y minus 12x cubed minus 12xy squared all over 12x squared y plus 12y cubed minus 100x. Okay, and then I can simplify this a little more. I'm going to divide out a 4 on the top and the bottom. So I get 25y minus 3x squared x cubed minus 3xy squared all over 3x squared y plus 3y cubed minus 25x. All right, so we're halfway there because now we have to find the slope when at the point 3, 1. So we're going to use our equation. We're going to say dy dx evaluated at 3, 1. Okay, and I'm going to cheat and I'm going to take this with me. All right, so we're going to take that with us. And now I'm going to substitute 3 and 1 in for x and y. This is my x and this is my y. So I get 25 times 1 minus 3 times 3 cubed minus 3 times 3 times 1 squared all over 3 times 3 squared times 1 plus 3 times 1 cubed minus 25 times 3. Okay, so I got 25 minus 81 minus 9 all over 27 plus 3 minus 75, which I got as 13 over 9. So dy dx evaluated at 3, 1 would be 13 over 9. And this is our solution. That's the slope at 3, 1. Love it. Okay, last example, we're going to take the second derivative of 4x is equal to 10. So I see on the left, we have some product rule happening. So the left is 4x and the right is y. Lefty right, righty left. Left is y. Right, the derivative of the right is 4. I do not need to add on a dx dx. plus the derivative of left d right. Right is, I did this opposite. It doesn't really matter, but I'm going to do it for consistency. Okay, so left is 4x. D right, the derivative of y is 1 times dy dx. So left d right plus right d left. Sometimes if I write it, it helps my brain out. Okay, so then I do add y times the derivative of the left, which is 4. And that equals to the derivative of 10, which is 0. So I get 4x dy dx plus 4y is equal to 0. All right, now gather our dy dx's on one side. So I'm going to subtract 4y, giving me, okay, so I get 4x dy dx is equal to negative 4y over 4x, because I'm going to divide by 4x. Then I'm going to simplify to give me dx. dy dx is equal to, cancel out these 4's here, is equal to negative y over x. And I'm just going to remember that I need to save that for later. We are going to now take our second derivative. So d squared y over dx squared. And I see here I have a quotient rule. So I'm going to use the rule low d high minus high d low over low squared. I get d, the second derivative is equal to, x is the low, the derivative of the high is negative 1 dy dx minus the high, negative y, times the derivative of the low, which is 1, over x squared. Make it pretty. I get negative x dy dx plus y, yes, plus y over x squared. The last thing to do is, I am not loving this dy dx, but isn't there a different way that we wrote dy dx? Yes, it's negative y over x. So I can plug that in for dy dx. So I get d over dx squared is equal to negative x times negative y over x plus y all over x squared. The x's cancel, and I have y plus y over x squared. So the second derivative is 2y over x squared. Sorry it took so long.